Hello all. Today we are going to perform virtually the specific gravity by Pycnometer or density bottle method. The IS code we are following IS 2120 part 3. In this part 1 and part 3, you have two sessions, session number 1 and session number 2. What it designates, session number 2 is with respect to the density bottle method, and session 1 is density bottle method and session 2 is Pycnometer method. Now, both the methods, the procedures are the same, but the change with the equipmentation is a bit different. Okay. In the Pycnometer and density bottle, how they look, you need to know that. Okay. This is, is it visible? Okay. Now this is your density bottle method, 50 ml bottle you'll be having, right? Another bottle you'll be having, this is the Pycnometer. The Pycnometer is with 500 ml. Now, need to understand what do you mean by this specific gravity. The specific gravity in general terms, I'll be saying here, if someone asks me, what do you mean by specific gravity? The specific gravity is a measure of the material density, mass per unit volume, as compared to the density of water, right? At specified temperature or 26 degrees centigrade, I'll be telling you, right? Any material, what we are going with, we are comparing with the density of water. I'll be saying it as specific gravity is nothing but the density of the object which we are measuring divided by the density of the water, right? This is a simple one. Yes. Now, so what do you mean by this 23 degrees centigrade? Why we are keeping? As we are comparing with respect to water, right? Now, why we are specifying this 23 degrees or 27 degrees, right? Now, this 27 degrees or 23 degrees, we are mentioning that we'll be saying that the specific gravity of the water is 1. Now, at a specified temperature of 27 degree or 23 degrees, we'll be mentioning with the window. Okay. Specific gravity of water 1, if temperature is greater, then the specific gravity of the water can change. Okay. So with that standard temperature of 23 to 27, with the window, the specific gravity will be 1, will be mentioned. Right. So we'll be in the definition itself, we'll be specifying that. If the material has the specific gravity below 1, right, then I'll be saying it as it floats on the water, right? Or else I'll be saying yes, it will be very prone to erosion due to the wind or rain. It also indicates of higher organic materials not properly incorporated or the homogenized, I suppose, right? Now, how do this experiments goes on, right? We need to understand this. Okay. Now, whatever the materials required for this experimentation is, this is your pycnometers, right? As I've shown you in this, this is your pycnometer and this is your density bottle. Okay. Now, this density bottle is with the 50 ml. And then what we are going with it, we are finding out the specific gravity of soil, right? Now, specific gravity of soil, rather, soil will be a sample. Okay. The sample which you are using for this experimentation should pass 425 micron ISCU. Okay, this is your CUs. Okay, we have different types of CUs numbers. We'll be having 4.25, right? 2 mm. We'll be designating these are the CUs, right? Familiarly, we see the CU as like this, where you will be going with the T and O, where you are screening it, right? These are the ISCUs. Now, if I am saying that the CU has 425 microns, right, then it has a dimension of that. Okay, 425 micron ISU passing the sample we are taking into account. Firstly, whatever readings here is observation table. Firstly, I'll be writing down the pycnometer. Okay, just for your convenience, I'll be typing over here. I'll be writing the sample pycnometer number as 1. Okay, क्योंकि पाइक्नोमीटर ज्यादा लैबोरेटरीज में 10 रहते हैं, 20 रहते हैं, अलग अलग वेट्स रहेंगे उनके, तो कंफ्यूजन ना हो सके, we'll be taking the writing on the bottle there with the pycnometer which we have taken is sample pycnometer number bottle number will be writing as 1. Okay. Now mass of empty pycnometer m1 मतलब जो आप pycnometer लिए हो उसका मास लिखेंगे हम लोग. ओके, वेट करेंगे, वेट वेविंग में, वेट करके and then I'll be writing. Then I'll be giving a reading as, so ये कितना आया, I'll be writing as the pycnometer weight, empty weight is 566 grams. Okay, just I'll be mentioning here sample in the grams. The next one is the mass of pycnometer plus soil. Okay, in this you have to add the soil which has passed through 425 micron IS sieve. Okay, so ये कितना डालना है? Okay, the IS code says we are implementing 1/3 of the soil by the volume of the pycnometer with respect to the volume of the pycnometer, right? So we are implementing the 1/3 of the soil which has passed through 425 micron IS, right? Okay, now that is your my M2. Okay, W2. I'll be writing the M2 is my, I'll be saying 766 grams. Okay, the next one. Now for the same one, we have to add water. Which water? Distilled water we have to add. So distilled water add karna hai, and then make it full completely. Make it full. Okay, please listen. Make it full and then stir it so that the soil present here, 1/3 of the soil which we have added in the pycnometer, has to be completely saturated. That should be our concern. Please ensure that this soil which you have implemented 425 micron past, it should be saturated completely. If you find white patches on this bottle from the outer side, then that means you haven't stirred or the soil is not saturated completely. Stirrer, ensure with the help of the spatula, ensure that it should be saturated, or else keep the soil sample by putting the water, keep the soil bottle with a 2 hours or 6 hours with some time, for some time. Okay, and then you will be getting the surety that the soil is saturated. Then make it full. Okay, and then what do you do? Take the measurement, weight of that. We will be saying it as M3. Okay, M3 I'll be writing it as 1592. My readings this. Okay. Okay. The next one is mass of pycnometer plus distilled water. Okay. Okay. Now what you do is take out this complete sample. Okay. पानी निकालो and soil को यहाँ पे निकाल दो. निकाल के इसको wash, completely wash करो. Okay. Wash करके and then completely take the water, distilled water, and completely filled with the distilled water itself. The pycnometer will be filled by the distilled water completely. Okay, and take the weight of it. We'll be calling it as M4. Okay, my M4 result are 1469 grams. Okay, now what you have to do is we'll be going with specific gravity is equals to, it says specific gravity क्या बोलता है? Density of the object. Density of the object divided by density of the water will be calling it as. Right? Put up the values over here. This is M2 minus M1. M2 क्या होगा? That is your pycnometer plus soil. Right? Right? अभी क्या होगा? M2 minus M1 मतलब M2 minus M1 मतलब soil का weight मिल गया. तुमने कितना डाला है? Right? You are not knowing how much the soil you have implemented. 1/3 of the volume डाला है. तो soil कितना डाला है? Weight देखा है तुम लोगों ने. यहाँ पे मिल जाएगा. Divided by M4 minus M1. M4 मतलब क्या हो गया? M4 मतलब जो तुमने पानी डाला है completely, right? Minus M1, right? M4 minus M1. यहाँ पे ना M4 minus M1 मतलब water, distilled water जो weight कितना है वो मिल गया तुम लोगों को, right? Minus M3 minus M2. M3 यहाँ पे है, M2 यहाँ पे है. मतलब जब तुम saturated soil होती है तो कितना weight होगा? That is the weight of the solids मिल जाएगा with saturated. So we will be getting as this one. Right? Now this is with respect to soil, nothing but the object, and this is the density of the water you will be getting. Right? Okay. Then once you simplify this, then you will be getting the answer as मेरा आंसर आया कितना है? 2.6 is my answer. Specific gravity is 2.6. Now the question arises, sir, what do you mean by this GL? Okay, this GL is nothing but specific gravity of the liquid which we have used. We have correction factor for this specific gravity. The soil sample which you have taken, okay, the soil, I repeat, the soil sample which you are taking, if it is very rich with the mineral content of dissolved salts, I repeat, the soil sample which you are taking considering for the experimentation, if it is very rich with the dissolved salts, then if you add the distilled water, it dissolves. Then you will be getting the error with the experimentations. Clear? So if you already know that this soil is completely rich with the dissolved salt, then go with the we'll be saying it as kerosene. I'll be taking the example as we'll be going with the kerosene, use of kerosene rather than distilled water. Clear enough? Now specific gravity of kerosene. अभी kerosene use कर रहे हो क्योंकि the soil sample which you have taken is very rich with the dissolved salts. Then kerosene लिया. Kerosene का specific gravity कितना रहता है? We'll be saying it as 9.6 or 9.3 रहता है. Okay, specific gravity of kerosene. You can check it out in the Google, and then you can check it. Clear? Then we'll be getting the specific gravity and results. Now this is not proper. Only one taking the soil sample. The same soil sample, okay, the same soil sample has to be taken another with a passing through 425 microns and repeat the experimentations. What we are doing as per the code, it has been said the sample 1, 2 and 3 has to be taken. The same sample has to be executed with the repeated trials of 3, and then you will be getting 3 answers with the best mean of it. We have to derive, and then that is your specific gravity. अब जो समझो कि specific gravity और एक trial में I have got with the 2.8. This is if I am getting this, like consider another trial 2.6 आ गया, first trial, second trial 2.8 आ गया, that is completely wrong. Okay, the error with this, the difference between should not exceed 0.03. Then the testing has to be repeated once again. Clear? Is it right? Okay. Chalo. So, Abhi, what is the use of the specific gravity? What is the use of the specific gravity? We find out here specific gravity of the soil. Then what is the use of it? The specific gravity will be used later on to evaluate and for the design purpose. For what design purpose? To find out the voids ratio, to find out the saturated densities, okay, to find out the bulk density too. We will be using this. Okay, here are a number of parameters where by this basic specific gravity we can find out the various parameters further. Okay. For this pycnometer or density model which we are going with the experimentations. Okay, so the question arises, when to use this density bottle and when to use this? Procedure the same, right? Then we have a difference with this. Now need to understand the different shapes of the density bottle and the pycnometer. As you are aware that how this pycnometer bottle and the density bottle looks like, right? Now you are going with the execution 1/3 of this and then 1/3 of this and then full of water and empty weight of the pycnometer bottle or density bottle plus full of distilled water. You have added and then executed the specific gravity. Now my question is why these bottles are with a heap at the top? First question. Another one is if they are heap at the top, I will answer it. They are with the inverted V. Why? Because once you go on with the increasing, we will be getting the meniscus correction form. Due to the reduction in the meniscus correction, so they are hooper at the top. Sure. Now, what do you mean by this meniscus correction? Let me explain here. Your bottles are like this, right? Okay. A small hole at the top. If you observe it, have you observed it? Just look at it. यहाँ पे है ना, ओके, टॉप व्यू से देखो तो पता चलेगा जो ऊपर आता है यहाँ पे क्या है, स्मॉल होल है, वेंट है. ओके, जब तुम लोग फिलिंग करते हो एयर क्या है पास होने के लिए क्या होता है, यहाँ पे एयर वी हैव अ वेंट ओवर हियर, स्मॉल होल. ओके, of diameter hardly a 3 mm 4 mm का diameter रहता है वो है. Okay, the same case डेंसिटी बॉटल्स में क्या रहता है जब वैक्यूम ये कैप रहेगा यहाँ पे स्टॉप तो यहाँ पे एक थिन कैपिलरी एक फ्रिंज है यहाँ पे फ्रिंज इज नथिंग बट अ होल फॉर द एयर लॉस के लिए यहाँ पे रहता है. ओके यहाँ पे भी सेम कंडीशंस लाइक दिस. ओके यू कैन सी द थिन लाइन ओवर राइट. यहाँ पे क्या कैप को एक थिन कैविटी ये रहेगा कैविटी लाइक. फाइन. नाउ why it is ऊपर at the top you can see the both the diagrams over here. Pycnometer भी देख सकते हो और density bottle भी देख सकते हो. They are with the inverted V like shapes, right? Why it is and all? Because of correction of meniscus. Now what is this meniscus correction? Let me explain. Okay, you have like this two bottles like this. ऐसा कुछ दिखते हैं वो दोनों भी bottle तुम्हारे. Okay. You have a cap over here. Now, as you people can see, when we have learned about this pipette, burette, we have learned with the 11th standard, 12th standard, 10th standard, make experiment with the chemistries and all. People are familiarly with the chemistry labs and all for the pipette and burette. So once you are taking down the readings, you have once you insert it, you have like this shape. If you are inserting the water and all liquids जब करोगे तो ऐसा दिखे है ना. तो we'll be calling this one as this is your upper meniscus. Okay, and this is your bottom this line. Okay, this is your bottom meniscus ऐसा बोलते थे हम लोग. एंड रीडिंग्स कौन सा लेते थे हम लोग? बॉटम मेनिस्कस जो रहता है रीडिंग वो हम लोग कैप्चर करते थे एंड देन वी हैव टू राइट डाउन इन द ऑब्जर्वेशन टेबल. यस और नो? डू यू एग्री विद मी? Now the same case when you have if you have with this area thin capillary area then this meniscus is observed. ये दिखाई देता है. Once you go with the cross sectional area with a larger diameter cross section area with the larger then the meniscus will be there but it won't be seen to you properly. Don't. Meniscus will be there is formed. Okay. Now if I make this bottle with a Hooper shape like this. Okay. Now what happens? As I go with the rising up, then what happens? The meniscus will go down. मतलब meniscus क्या होगा? Vanish हो जाएगा. पानी भरते गया यहाँ पे distilled water तो क्या होगा? ये meniscus vanish हो जाएगा. In the same case over here. Okay, meniscus कैसा रहता है? वो रहता ही है. तो जब मैं V shape inverted V में move हो जाऊंगा, meniscus zero हो जाएगा. So this is for the meniscus correction. Why these shapes are like this? Clear? For the air vent, यहाँ पे है air gap, air vent के लिए यहाँ पे छोड़ा गया है. No issues with it. Okay, in the bottle, density bottle and pycnometer, both the cases. For different type of the soils, we have different specific gravities, right? The specific gravity कैसे find out? With the experience, we can say. If you have a large quantity of the quartz present in that soil, right? Then we'll be saying large quantity of quartz, then we'll be straightforward, we'll be saying 2.6, 2.7 रहेगा specific gravity. If you have more organic materials, organic matters, मतलब we'll be saying as roots, shells, ऐसा कुछ रहा, the specific gravity बहुत ही कम होता है. Okay, I'll be showing you some of the values where we are stopping this is not a hard and fast rule, we'll be getting the same. It can vary. The judgment has been given over here, a bit of it with the experienced hands. The sand की specific gravity you will be getting 2.6 to 2. With the range of 2.6 to 2.67. Okay, hard and fast नहीं है, इतने में ही मिलना है. Depends on your soil samples. No issues with it. Okay, these are the homogeneous soil samples where we are stating forward that silty sand का इतना रहता है. Soil with mica and iron rich रहता है, वजन ज़्यादा रहता है. That is it. Okay, now please do understand that. यहाँ पे देखो, gravels बड़ा रहता है. Do you agree with me? Right? Okay. Sand उसके से छोटा रहेगा. Okay. Silty clays उसके से छोटा रहेगा particles. Right? Okay. This I will draw over here. Please do understand. Okay. Sand particle ऐसा इतना रहता है. Okay, I will be saying is gravel इतना बड़ा रहेगा, sand इतना रहेगा. Okay. And then we will be coming for the microscopic. I'll be saying this is the silt itna rahega, clay itna rahega, big chota rahega. Hai na? So one thing to observe over here, as the particle size, coarse material ra. Now we can observe over here as the size of the grains. Okay, I'll be saying it as this is your gravel, this is your sand particle, this is silts, okay, and this is your clay particle. I'll be saying this. Now, as the particle increases, gravel, then I can observe this sand and gravel are with a lower specific gravity. As the fineness increases, small size, then the specific gravity increases. If you find any organic materials, mixture of the organic soils in this type of the composition, then the specific gravity will be completely lower than 2. Okay? Clear? As the gravel sizes are bigger or larger, the specific gravity is on the lower side. The fineness increases for the silts and clays. यहाँ पे ज़्यादा है specific gravity आता है. Okay, you can observe here the specific gravity will be, I be corrected. Specific gravity is lower side on the grains, and with the fineness, the specific gravity is increased. Why it is so? It is because of the specific surface. This is your specific surface, right? If I am saying the specific surface, right? अभी समझो यहाँ पे एक bucket है. This is my bucket or beaker. I will be adding the particles over here of the sand completely. This is the sand particles. I have made the sand particles to fill this beaker, right? And coming for the clays, I have filled all the clays in this beaker completely again. Okay, by adding with the same volume, I need to mention with the same volume of the beaker, I have added the materials over here. The full of sand, here the full of clays or silts and clays. Okay. Now, if I measure the specific surface of individual summation of all the particles, if I measure the summation of all the particles over the silts, then which will be the higher? This will be the higher side. Okay. In this learning, we have learned about this. Specific surface, if it is increasing, the specific gravity also increases. If the specific surface decreases, the specific gravity will lower down. This is the thinking. This is the thought teach we have got from this specific surface with respect compared to the specific gravity. Okay. The difference between the pycnometer and the density bottle, which we are taking into consideration for to find out the specific gravity, is the density bottle experimentation. If the soil sample is completely fine, then we will be going with the density bottle. If the soil sample is coarse grained or to the medium grain to the coarse grain, then we will be going with the pycnometer bottle. Right? So the question arises over here. How do you say that it is coarse grain, it is fine grain? How do you say it? Right? How do you ensure it? Then as per the IS code, in the classification of the soils, it has been mentioned over here. Please listen carefully. This is your sieve. Okay. For this sieve, which sieve it is? The sieve number is 4. I'll be writing it as 75 micron ISC. Okay. Before to starting with this explanation, I need to ask the question that if I say sand and aggregates, what do you mean by sand? You'll be calling it as, it is fine aggregate. If I'm saying gravels, it is coarse aggregate, right? Do you agree with me? Right? Now,
yes, sir.
how do you differentiate this coarse aggregate and fine aggregate? The sieve is 4.75 mm. Okay, if I am implementing some material, if it is passing down, okay, which is passed down, this is known as fine aggregate, I'll be saying, and which are retained over here, this is known as coarse aggregate, and I'll be saying. Clear enough? Yes or no? This is aggregate, please remember. Okay, always, how do I differentiate coarse aggregate? Okay, coarse aggregate, I'm writing AGG aggregators. Okay, aggregate and fine aggregate. We have distinguished with respect to 4.75 mm ISU. If I am saying coarse fine soils and coarse soil, coarse grained soil and fine grained soil, then how do you differentiate? The differentiation is with a 75 micron ISU. If the soil which you have taken as a sample over here, we are implementing and sieving it. If the soil sample has been retained, I am saying, if it is retaining more than 50% of the soil sample is retained, 50% of the soil sample is retained on the 75 micron ISU, then it is coarse grained soil. More than 50% if it is retained over here. If more than 50%, of the soil is passed to 70 through 75 micron ISU, then we'll be calling it as fine grained soils. Clear enough? Coarse grained soils and fine grained soils. What is the criteria? It is 75%, 50% more than. If it is retained, then it is coarse grained soils. If it is greater than 50% is passed through 75 micron ISU, then it is fine grained soils. If this soil is present, fine grained soil is present, specific gravity find out करने के लिए हम लोगों को कौन सा bottle लेना है? It is come on, it is density bottle लेना है. Right? If it is with the medium to coarse grained soil, then कौन सी bottle लेना है हमें? जल्दी बोलो.
Pycnometer.
Right. Clear? समझ में आया?